So this is going to be another one of those videos where we're going to have a lot of examples. Right here is pretty much all of the notes. Now, normally I would go ahead and take the time to derive these formulas, but that's almost like a separate class period by itself. And so we're just going to accept that these formulas are true. Speed things up a little bit. I do want to point out some things though in what's going on here. So these are called the sum and difference formulas. Sometimes you'll hear them called the addition-subtraction formulas. Obviously the same thing. And they're called that because we are adding and subtracting angles. So you can't, I mean, it may be tempting to go, oh, well, just distribute the sign. But remember, you can only distribute when you got multiplication on the outside. This does not mean sine times u plus v. This is sine of u plus v. Totally different operation. Do not distribute. Big mistake that a lot of people are tempted to make. But we do have a formula for what the sine of u plus v is equal to. And this is a formula right here. It is the sine of u times the cosine of v plus the sine of v times the cosine of u. And then if it's a minus sign instead, this is a minus sign right here. These are another pair of formulas that you should memorize. Actually, all of these are another set of formulas you should memorize. But the good news is you can really think of these two as the same equation. I mean, if it's a plus sign here, it's a plus sign here. And if it's a minus sign here, it's a minus sign here. In fact, because of that similarity, you'll often see, instead of it written as two separate equations, you'll often see it written like this. Plus or minus, plus or minus. So then, same kind of thing happens here with the cosine, the sum and difference for cosine. Cosine of u plus v, cosine u, cosine v, minus sine u, sine v. And then if this sign changes, this sign changes. Except now we have a problem if we're going to try to combine it to the same equation, because if this is a plus, this is a minus. If this is a minus, this is a plus. We need to let people know that these signs are actually the opposite of what you see here. And that's okay. We have, just like we have a plus or minus sign, we have a minus plus sign. And there really is. It's a minus plus. That's how you read it. U plus or minus v, this is minus or plus. So, you know, whatever's on top here goes with there. So if it's a plus sign here, it's a minus sign here. If it's a minus sign on this side, it's a plus sign on that side, which you can see matches this. And then similar things happen with the tangent. Unfortunately, tangent, we're going to have to do ratios. We have to do fractions. That's going to make rationalizing denominators fun. Yay! But tan of u plus v is tan of u plus tan of v over 1 minus tan u tan v. So if it's a plus sign here, it's a plus sign on top and a minus sign there. If it's a minus sign here, it's a minus on top and a plus sign. So the numerator matches, the denominator changes signs. So plus or minus here, it's a plus or minus on the top, and it's a minus or plus on the bottom. So these are going to be the formulas we're going to use in today's examples. And these are on that formula sheet that are in, they're in Module 6 if you go down to the resources. Okay, so let's just look at some examples now of how we actually use these things, or can use them. Alrighty, let's do this. First of all, the point of this example is to show that distributing does not work. You can't distribute the sign to both angles and get the same answer. For the one on the left, we're going to use that formula. So, and again, I encourage you, write down the formulas first. Don't just like evaluate them. Get used to writing them down. It's going to help you remember. So if I let u be 135 degrees and v be 30 degrees, when it's a minus sign here, we got sine of 135 degrees times cosine 30 degrees minus sine of 30 degrees cosine of 135 degrees. And then we work each individual piece. Sine of 135 degrees is in quadrant 2, so that's where sine is positive, and your reference angle is 45 degrees. The sine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. I sure hope you guys took my advice and memorized that table. Otherwise, your homework's going to go a lot slower. So I just evaluated each one of these. And then we just multiply. So we got root 6 over 4 And then we'll have minus and negative, so that's going to turn into plus root 2 over 4. I'm going to combine into a single fraction. We have a common denominator already. And there you go. When you check your answers in the back of the book, I just want to show you, they will have actually written the answers like this, which is totally fine. They factored. There's a root 2 in common in the top, and they just factored out the 4 from the bottom. But, you know, if you distributed this back, you'd see you get this answer. Either way is fine. It doesn't matter. So that's this answer. If we go to evaluate the part B, sine of 135 degrees, we already found was root 3 over 2. Yeah, it's not that. How about root 2 over 2? And sine of 30 degrees is 1/2, and, well, definitely easier to evaluate, but also definitely not the same answer. So do not ever distribute your trig function. That's example 1. Let's look at the next one. Okay, so these actually come in handy also for finding exact answers for things that don't have a nice reference angle. Like 255 degrees, if we think about that, that's in quadrant 3 with a reference angle of 75 degrees. That's not on our table. And that's okay, because we have another way of evaluating it. Let's see how we do it. So they've given us a hint here. 255 degrees is the same thing as 300 degrees minus 45 degrees. And oh, well, that kind of looks like we can write our, or use our sum and difference formulas. So that's sine of 300 degrees, cosine 45 degrees, minus the sine of 45 degrees, cosine 300 degrees, and now we just evaluate. 300 degrees is in quadrant 4, where sine is negative. It's a reference angle of 60 degrees, and the sine of 60 degrees is root 3 over 2. Cosine of 45 degrees is root 2 over 2. Sine of 45 degrees is root 2 over 2. And again, 300 degrees is quadrant 4, where cosine's positive. Reference angle of 60 degrees, and the cosine of 60 degrees is 1/2. So we're going to get negative root 6 over 4 minus root 2 over 4. And so we could write our answer like this, or we could factor out the negative and just put it in front and make the entire fraction positive. Now be careful if you're going to write it like this, because that negative must be clearly in front of the fraction bar, showing that the whole fraction is negative. Now, that negative can go in the top or the bottom, but not both places. Because remember, we've looked at this in the past. Negative a over b is negative a over b is a over negative b. A negative divided by a positive is negative. A positive divided by a negative is negative. But this does not equal, let me make that not equal to look better. This does not equal negative a over negative b, because a negative over a negative would be positive, not negative. So just be on the lookout for that. Part of your fluency to get used to that. This negative in front of the fraction is making the entire negative, or the entire fraction negative, but that does not mean both top and bottom is negative. The top or the bottom can be negative, or you can think of the entire fraction being negative. And again, you know, you could factor out the root 2 over 4 if you wanted, like the previous example. There you go, that's all there is to it. Okay, let's try another one. All right, so this is going to be very similar to what we did before, but this time they didn't give us a hint of what to start with. We have to figure out what to use. So we have to think about two angles that either add or subtract to 285 degrees. where we can calculate there. Let me go back here for a second. Maybe not both angles may not be directly off of our table of values. 45 degrees in this case was on our table of values, but 300 degrees wasn't, but it had a reference angle that was. The reference angle of this is 60 degrees, which is on our table. So you kind of have to think about this one. So let's think about, if it ends in a 5, you're going to have to use 45 degrees somehow, because that's the only way to get the 5. So what happens if we subtract 45 from that? We get 240. Oh, that'll work. So tangent of 240 degrees plus 45. And there's almost always multiple ways you can split this angle. So this is only one way. But you're still going to get the same final answer. So yes, there's going to be more than one way to do these. All right, so now we got to think of our formula for tangent. So if you look at the formula sheet, you will see that the sum formula for tangent is going to be tan u plus tan v over 1 minus tan u tan v. So tangent of 240 degrees. 240 is in quadrant 3 with a reference angle of 60 degrees. Quadrant 3 tangent's positive, and the tangent of 60 degrees is root 3. Tangent of 45 degrees is 1. And luckily we just have the same answers here. So we have root 3 plus 1 over 1 minus root 3. However, we have to rationalize our denominator. And remember, when you have two terms in the bottom, you got to multiply by the conjugate of the bottom. Same thing, just change the sign. Now we multiply. If you were to fully distribute the top, you got root 3 times 1 plus root 3 times root 3 times 1 plus 1 times root 3. But on the bottom, remember the shortcut for conjugates, you only have to do first times first, last times last. A squared minus b squared. So it's going to be 1 minus 3. So in the numerator, combine like terms, and we're going to have 4 plus 2 root 3. And in the bottom, we're going to have negative 2. So we can divide, and we get negative 2 minus root 3. And there's our final answer. So the trick is just figuring out which two angles you can split it into. And like I said, there's going to be multiple ways you can do this. But then just plug into the formula and evaluate. All right, next example. Okay, so now this is going to be a little more challenging. Now we're dealing with radians. It's the same idea. You're going to want to find two angles that add or subtract to 5 pi over 12, where we can deal with them. They're using, reference angles will be on our chart. So how are we going to do this? Well, there's a nice thing that happens. This is my strategy. Different people have different strategies, but here's what I do. If you think about the angles that are on that table of values to memorize, there's 0, there's pi over 3, pi over 6, pi over 4, pi over 2, 3 pi over 2 pi. I think those were all the angles on there. Look at the denominators. 2, 2, 4, 6, 3. And of course we have a 1 and a 0. It's just any denominator you want except 0. So we're going to want, and any reference angle to these are going to have the same, actually, well, these two don't have reference angles. The 3, 6, and 4, any reference angles to these, or if these are reference angles to something else, they have the same exact denominator. So we need to find two angles with denominators of 3, 6, 4, or 2 that will add up to this. So let's think about add or subtract. Let me write down what I'm trying to say. We got 5 pi over 12. Now, I don't know if it's going to be plus, or maybe we'll have a better time finding two angles to subtract. Now, in order to add or subtract fractions, you got to have a common denominator. 12 is not in our list, so these fractions have to simplify. And the only way they're going to simplify is if the numerators have a common denominator to the 12. So for instance, if I tried to do 4 pi over 12 and 1 pi over 12, sure, these do add up to 5 pi over 12. And yes, this one will simplify to pi over 3, which gives us one of the denominators we're looking for. But this guy does not simplify, and we're stuck again. We can't evaluate by hand unless we do, again, splitting it up and trying to do that. We'll just be spinning our wheels. So what I want to do is I want to find numerators that are going to add up to 5 pi over 12, but also have common factors with 12 so they simplify. So that one doesn't work. But if I did 3 pi over 12 plus 2 pi over 12, that still adds up to 5 pi over 12. And these do simplify to get the denominators that are on our chart. So I'm going to use that one instead. So that's a strategy I pick. Like I said, different people have different strategies, but that's how when I'm dealing with radians, how I find a way to split my angle up so I can use the sum and difference formulas. So now that I have that, let's just go ahead and do it. So we have cosine of 5 pi over 12 is equal to the cosine of pi over 4 plus pi over 6. And then looking at our sum formula for cosine, it's cosine pi over 4, cosine u, cosine v, minus sine u, sine v. And then these angles are all right off the chart. We have root 2 over 2, root 3 over 2, root 2 over 2, 1/2. So we have root 6 over 4 minus root 2 over 4, and it equals root 6 minus root 2 all over 4. Dun, dun, dun. Yay! So there's that example. Okay, let's look at the next one. Okay, so this one says secant of v minus u. I didn't give you guys a formula for that, but that's okay. We can find cosine of v minus u and then just find the reciprocal. They're reciprocals. But now what do we do here? We're given sine of u. Oh, let's go ahead. Okay, so let's work backwards. Let's start from, we want our final answer for secant v minus u. So we're going to have to first find cosine of v minus u. And we know that cosine of v minus u is equal to cosine v cosine u plus sine v sine u. So if we go ahead and start plugging in, cosine of v is, oh man, hang on a second. I wrote this down wrong too. That should be cosine of v. So definitely change that one. Sorry about that. But now that we have that, hey, that's fortunate. Now we have cosine of v. Cosine of v was given as 7 over 25. Cosine of u, we have sine of u, but we don't have cosine u. What do we do? Well, draw a triangle. When in doubt, draw it out. It does say both angles are in quadrant 4. So I'm going to, and you have to draw two separate angles because these are two separate triangles. Or sorry, two separate triangles because they're two separate angles. So for u, the sine of u was negative 5/13. And again, that's along the negative part of the y-axis, so that's negative. The hypotenuse is positive. Pythagorean theorem will tell us that this is 12. And then if I draw a separate triangle, do not try to combine these. I'm going to say that over and over again, and there's still going to be people that try to make them into the same triangle. They are not. Cosine adjacent over hypotenuse. And when you do the Pythagorean theorem, you're going to find this is 24, but be careful. That's on the negative side. So I have to make it a negative 24. But now that I got that, now it's easy. I just plug it in. So cosine of u, now I can find it. Looking at the first triangle, that is 12/13. Sine of v is negative 24/25. And sine of u is negative 5/13. And then we go ahead and work it out. 25/13 times 13. We got 13 quarters. It's going to be $3.25, $3.25. And 7 times 12 is 84. We'll have a negative times negative, so we stay positive. That's 120 over 325. So 204 over 325. Whoop. Now that was cosine. We want to find secant. So we just have to flip it. Almost forgot. So secant of v minus u is 325 over 204. And there you go. All right. 2 more examples, I think, if I remember right, and then we're done. Huh. Oh boy, it's one of those algebraic expression ones. Yay! I actually really like these. I know, I'm weird. But what do we do? Again, do not distribute. This is not mean multiplication, so you cannot distribute. But remember, these are angles. Inverse trig means angles. The angle whose cosine is x, the angle whose tangent is x. So let's see, if I let u equal arc cosine x and v equal arc tan x, then what I'm really doing here is cosine u minus v. It's just in disguise. And then it's kind of a combination of what you've done in the past. You're going to want to draw the triangles and then kind of work from there. So let's draw the triangle for this. Now, cosine has a range that's in quadrants 1 and 2. So we have to draw a triangle in quadrant 1. And a triangle in quadrant 2. But this is u. So cosine is adjacent over hypotenuse. And it's also adjacent over hypotenuse. It's okay that we're on the negative side here because the value of x can be negative. So we're okay. So then, using the Pythagorean theorem, we'll find that this third side on both triangles is the square root of 1 minus x squared, and it's along the positive part of the y-axis on both triangles. So, phew. And most of the time, you get the same triangle. So we don't have to worry about anything special there. Tangent, its range is in quadrant 1 and 4. I don't know why I started with quadrant 4, but I did, so we'll go with it. Tangent is opposite over adjacent. And quadrant 1, opposite over adjacent. And so it looks like we'll get the same triangle here as well. Yay. So we really only have to look at one triangle for each one. But now, let's just do it. So we were started with cosine of arc cosine x minus arc tan x. And because I did define what u and v are, I can rewrite this as cosine u minus v, which is cosine u cosine v plus sine u sine v. And now I can go ahead and use my triangles. So looking up above, I didn't label that d. Cosine of u is adjacent over hypotenuse. Cosine of v is adjacent over hypotenuse. Sine of u is opposite over hypotenuse. And sine of v is opposite over hypotenuse. So it's x over root 1 plus x squared plus x square root 1 minus x squared over the square root of 1 plus x squared. They have the same denominator, so I can combine the top, keep the bottom the same. And my goodness, definitely don't rationalize this denominator. And there you go. There's your answer to that one. So let's take a look at one more example. Oh, it's a solving equations one. Yay! Oh my goodness, but what are we going to do? Well, the thing I notice is it looks like sum and difference formulas here. So let's start off with the original. Here's the original equation. I'm just going to go ahead and expand this using the sum and difference formulas, and let's see what happens. So we get tan x plus tan pi over 1 minus tan x tan pi plus 2, and then sine of u plus v. Sine u cosine v plus sine v cosine u. Oh my goodness, that looks awful, huh? But the good news is we can evaluate some of this. Remember, tangent of pi is 0, and the cosine of pi is -1. The sine of pi is 0. So the first term just simplifies to tan x, because we have tan x plus 0 over 1 minus 0. Here, I'll actually write it all out so you can see it. So that first term that's how I'm getting just a plain old tan x. And then we have the sine of x times -1 plus 0 times the cosine of x. Well, that's going to be -2 sine x plus 0. Oh, that looks a little better there, doesn't it? Yes. Okay, so now let's try to figure out what we do from here. Well, remember, a good strategy when you get stuck, when in doubt, write everything in terms of sine and cosine. Let's see what happens. So tangent is sine x over cosine x. Can you figure it out? Can you see it? We can factor out a sine from both terms. If I factor out a sine, the first term I'm left with 1 over cosine, and the second term I'm just left with a 2. And now we can solve, excuse me, we can solve both, both of them separately. Oh, excuse me. Zero product property. Set each factor equal to 0. 1 over cosine x minus 2 equals 0. So this one's already solved. Let's see, I wanted to double check. We are in the interval 0 to 2 pi. So I only need to worry about one rotation Not all solutions in one rotation of the circle. Sine of 0 at 0 and pi. Over here I get 1 over cosine equals 2. If I take the reciprocal of both sides, I get cosine x equals 1/2. So I want to look at quadrant 1 and 4, where cosine's positive. My reference angle is pi over 3. So that's going to give me x is pi over 3 in quadrant 1 and 5 pi over 3 in quadrant 4. Putting it all together, I have 0, pi, pi over 3, 5 pi over 3. And there's our answer. So lots of different ways of using the sum and difference formulas, but now this kind of gives you a taste of what you'll see on your homework. Have fun.